everyone, and welcome to another live stream of Bone Studio. So today we are going to talk about animation nodes. And some time ago I did an animation nodes live streaming, but I think I only did it in Spanish. And I did things like a bit too complex because I come from a background where I'm half a programmer, half artist. I'm more or less like some kind of TD animation director, and I don't know, many things. But when I think about programming and about using nodes, I think in a programmer's way. So I tend to make things over complex. So now today what I want to show you is just a brief introduction to animation nodes and show you the differences of the basics of how it works and what are the basic nodes. So this live streaming, in case you are wondering, is going to get us like 1 hour, maybe less, but around 1 hour. And now I just remembered that I have to use my timer. Okay, my timer is in place. I hope everything is okay. Hey, Lord Odin. Hello, Derek. I know you are here because I told you. I told you to be here, man. Okay, so let's start. Basically, what is animation nodes? Animation nodes, please, let's set this clear from the beginning. Animation nodes, it's an add-on. It's not part of everything nodes. It's not part of particle nodes. It's not part of function nodes. Is not part of Blender itself. It's an add-on. And to get this add-on, you have to download it and install it exactly in the same way you do that for any other add-on. So here you can get animation nodes, and you will need the specific build for your operating system, because there is a build for Linux, a build for Mac OS X, and a build for Windows. And why is that? Because animation node is not just a simple Python script. Animation nodes needs to be compiled. And this is because it uses Cython or CPython to accelerate things. So the performance of animation nodes is much better than the performance of a simply programmed Python add-on, especially in repeating tasks with a lot of objects, a lot of iterations, etc. So now you can come here and, for example, let's say you are on Windows, so you go to Windows, download, and you download the zip file, and you can install that zip file in your Blender like any other add-on. So now we are in animation nodes, and you can see that this is what we are going to look today. What happens to my mouse? Come on. Okay. And it's a very simple animation, super simple animation, nothing special happening there. Okay, it's just this. But the beauty of animation nodes is that this is everything procedural. So for example, if I saw what is going on here, I can move this here, and you may think that nothing's happening because I have not enabled one thing that I'm not going to enable now, because I want to show you later what do you have to enable to make this react in real time. But if I go here and, for example, I move this here and I set a key and I press play again, you can see how this reacts. Okay, so nothing is keyframed apart from the empty object. And this is the power of animation nodes. Another thing we can do, for example, is that we can go here and we can say, okay, I want just 10 by 10. And I want to reduce this, the size, this, and you can see how this reacts to the location of the empty. Now I press play again, and it's reacting. So everything with animation nodes, it's procedural. And it's very easy because, as you can see, we use just a few nodes to do this. So let's go for the basics. Let's say we are in Blender, we just open Blender, this is my startup scene, nothing special. And let me delete everything well, everything except the camera. I want the camera. And this is it. So where is animation nodes? Okay, animation nodes is just another editor. So I have a workspace, a special workspace to work with animation nodes. And I created this myself. So it's not that animation nodes come with any workspace or anything like that. I just created it myself. But you can access animation nodes by creating another window, another editor, and changing it to animation nodes. Wow, that's hard. That's hard to find. Let's be honest. That's hard to find. So animation nodes, and now we are in animation nodes. But allow me to explain why do I want to use my own workspace. Derek, you say you told yourself to be here, but that is what I want you to think. So no, I told you. Okay, so in my workspace for animation nodes, let me create the camera space so I don't press any setting that is hidden by the camera. Okay, that's better. I have the viewport, obviously, and I have one outliner here, and this is the standard outliner configured with view layer settings, so I can see the scene as in the same way we always see the scene. I have the properties here that with animation nodes we use the properties, well, not too much, but we can use them. But I also have another outliner here. Why? Because this outliner is configured in scene mode. So I can see the scene and I can see any object I have in the scene without having to deal with collections. Because if I have, for example, all of this in a new collection called crap. Okay. And now I have this and this and this. And I have this in a new collection called crap 2. And now this collection is inside this collection, and now this collection is collapsed, and this collection is collapsed, and now I have to deal with all the collections, with all the order in the scene, and I don't want to deal with that. So they tell me that the audio is too low. Okay, raising the audio. I hope it's better now. Hello, hello, hello. Okay, I think it's better now. Thanks, VLC. So, because I don't want to deal with that collection things, because I just want to access all the objects in the scene, and this is better because I just want to access all the objects in the scene, and I want them to have them sort alphabetically. So it's easier to find if I have an object that is called sphere, for example. It's easier for me to find it and use inside the node tree. So I like to have this view to work with animation nodes. But usually this is useful for this is more useful for complex scenes more than what we are going to do now. So okay, this is why do I use my own workspace. So let's go to the next. Next thing is the node tree. Now we are in the animation nodes node tree, and that's it. So now you know how to use animation nodes, right? Well, not exactly. Why? Because for starters, we cannot add any node here. We can just add a new node tree. So we can have, in every scene, we can have different node trees that will do different things. For example, we can have a node tree that will set up some functions, and we can use those functions in a different node tree. So I will do an example of this later. But for starters, we just create a new node tree, and we have the classic two panels. We have the N panel and the T panel. In the N panel, we are going to be able to access different things from the node, different settings for the nodes. And in the T panel, we are going to access one very important thing, that is the auto execution. Because we want the node tree to be automatically executed, but not always. Why not always? Because it's going to create an overhead, and we don't want the CPU to keep working constantly in something that is not changing. So for starters, what I do, the first thing I do is to disable always, and enable tree changed, frame changed, and property changed. Keep in mind that this is going to depend on your needs, on your project, on what you are doing. So these three things, when they change, they are going to trigger the node tree execution. And let me drink a bit. Okay. So now we have our auto execution already configured, and let's do something with the node tree. Let's select this. Okay, I deleted the camera. Why do I delete the camera? Because it was the article of the, yeah. Okay. So now let me create a cube, and let's say that we want to move this cube. We just want to move the cube. So for that, we have to bring things into the node tree. Okay, it's super easy because we just want an object inside the node tree. How can we do that? We can press Shift A as in the viewport, but in the node tree, and we will get this long list of menus, submenus, with a lot of options. Okay, but if you want to think what should I look for, okay, let's go to object and then pick object. That's it. But this is an interesting thing. This is called object input, because animation nodes has two concepts: the inputs and the outputs. So for example, we are going to get, when we want to get the transformations of an object. Hello, see Papadakis. Oh, from Greece. Great, pretty country. I've been there. So for an object, we may want to transform the position of the object. Okay, so that's called transformation input. So if we go here, we can look for transforms input, and I can connect this object to this, and I will show you how to use this one later. And then let's say that with this I get the current information. I mean, the information I can see here. This is 0, 0, 0, 0, 0, 0, 1, 1, 1. Okay, location, rotation, and scale. But let's say that now I want to modify this transform. So we can go here. Let's connect. We have different options to populate this field. The first one is obviously the list. The second one is the I don't know how is this called. I don't remember how. The eyedropper. Okay, we have this eyedropper, and I can click here, and I can pick the object here, or I can pick the object here. It doesn't matter. Or I can use this eyedropper button. If I have the object selected and I press here, it will populate the field with the selected object. It's much easier. And some nodes will have an object input here, an object input field, so there is no really need to use this in this case. But this is made for when you have a complex node tree and you output an object from one point and you want to continue using this object, this modified object, and you will connect this to this socket. Okay, so the slot is going to disappear, the field is going to disappear. Now let's say that I want to set the transforms. Okay, let me check first what is the actual transform of the object. For that we have a node that is called viewer. So we can press Shift A and we can go to viewer. We have different types of viewers, but the simplest one is the simple viewer. So we can press viewer and we can connect this to this, and it's going to show us the information that is here. In this case, 0, 0, 0. If I manually modify these values, as soon as this gets executed, because right now it's not getting executed because the tree hasn't changed, the frame hasn't changed, and the property in the node tree, any property, no property has changed in the node tree. So the tree is not being executed just yet. Okay? So, but I can press execute node tree. So if I press here, you can see that now we have these values. Okay, so we can see that we have the data of the object. Great, let's modify this data. Let's disable this and let's put it here. So we can do different things. For example, we can get the vector, because this is a vector, x, y, z, it's a vector. So we can go here with Control A, we can bring up the search field. With F3, we are not going to be able to search for commands for nodes or in the from the animation nodes tree. From the animation nodes collection. Okay. So it's Control A or Shift A and search. Okay. So let me search, and I'm going to search to separate vector. And now we have a node. That will separate our vector into 3 simple components, 3 numbers basically. So I can connect this one to here, and let's modify this, and let's connect. And as you can see, we have 1.49, that is the same we have here, 1.49. So great. Now let's modify this value. Let's put math, for example, or add numbers. Add numbers, it's okay. And let's connect this number to this node, and let's put, for example, 1 or 3. But the cube hasn't been modified yet. But we changed it, the value. We changed the location. We're adding this. What's happening here? Okay, what's happening here is that yes, we changed a value, but this value is nowhere near linked to the object. This is just the object is telling us, hey, my position is this, and I'm giving you my position. And you can modify the position. You can do whatever you want with the position. But if you don't bring me the position back, I'm not going to know that you modified the position. So now we have a math. We have modified the x factor, the x number, the x value. And now we have to combine this to a vector again. So for that, Control A, combine vector. Okay? Here we have combine vector. And as you can see, we have 3 inputs, 1 output. So let's combine the vector, the x with the x, the y with the y with the y, man, okay, and the z with the z. And we have a vector. And where do we have to connect this vector? Okay, we have to connect this vector to an output, because we are going to get information from the node tree, and we are going to output this information into the scene. So we are actually going to modify the object. So let's do that. We have object transforms input. So what do you think we need? Object transforms output. It's that simple. So we go now, Control A, object transforms output, or Shift A, object transforms output. Okay, don't go away. Object transforms output. With this, and we get a node that is going to ask us, what do you want to modify? The position in all the values, just the x, just the y, just the z, the rotation, or the scale, or everything, because you may want to modify everything. So right now I just want to modify the position. And now what object is the one that you want to modify? So I could go and press here and pick this object, because it's the same I'm getting the position from, but this is a bit of nonsense. Why? Because we have this, so we can directly connect this to this one. And if we want to modify the node tree, if we want to modify the effect in the scene, and we want to change the object we want to modify, it's as simple as just changing this this node. So let's connect the object node to the object input. Okay, now we are modifying our object, and what is the location we want to put to that object is this vector. That's it. As you can see, the object has been modified. But now we find another problem. Why? Because animation nodes, it's just a loop. Okay, it's constantly looping as soon as the auto execution is going on. you're gonna discuss loops. Animation node loops still confuse the heck out. Yes, I want to talk about loops. Yes. And a pretty cool thing about not needing loops for many things. So now we have another problem. What is the problem? The problem is that since animation nodes is constantly updating when some of this is happening, and the information from the object is also changing, this is going to go up to the infinite. So it's not that now the position of the object of the cube is 3 meters in x value, because we are not telling this that the original position was 0, 0, 0, and now we want to sum up to add, we want to add 3 more to the x value. No, we are getting the object position, and we are getting the actual object position, and we are adding more value to the x number. So if I change this frame, this is going to change again and again and again and again and again, and it's going to go up to the infinite. Why? Because this value is being modified. Okay, it's time we execute the node tree. This value is being modified. And what happens if I enable always? That is the main reason why I don't want always. Well, it's going to happen this. Bye bye. And what happens, because I'm on frame 9, what happens if I go backwards in the timeline? Let's focus in the cube, and I'm going to go backwards, but the cube still goes forwards. Why? Because it doesn't matter, we are not using the time here, we are not using anything, we are just executing the node tree, and we are just summing up, adding 3 meters, it's time. So this is one of the problems you may find when you start with animation nodes, that the node tree is constantly executed. You have to keep this in mind. So let's do the things in a different way. Let's reset the cube. We have our cube here, and we don't want this to happen at every frame. So what can we do? With animation nodes, we have different ways of working with it. And one of the ways is the one that ITF was mentioning, that is loops. But we don't have just loops, we have loops and we have groups. And I want to show you these two things before I continue with this thing of controlling the modifications. So let's delete this, and let's explain what a group is, or what a subprogram is. If we go to Shift-A, we are going to hit here, and we have subprograms. And we have three types, mainly three types of subprograms: group, loop, and script. Yeah, the loop subprogram is still very confusing. It's no longer needed for all stuff, but I would like to understand them a bit better. Well, it's not needed, not always needed, but it's important when you want to have a node that kind of controls some complex situations. So it's not absolutely needed, but it's important to understand it. So the script subprogram, what it's going to do is to point towards a script, and you can go to the text editor and you can generate a new Python script that is going to do something with the inputs, with the variables you use in the script, and that's it. So you can do whatever you want. Okay. The second subprogram is the group. And what does the group does? Okay, let's go to properties and make it this bigger. Okay, what does the group does? What it's going to do is to how can I say it in English? Is that it's going to, obviously, it's going to group a bunch of nodes that will be executed as many times you want in the node tree. So let me explain. For example, let's create an input. Okay, an input is something, some data I'm going to give to the group. So it's like a function in programming language. So I want to input an object. Okay, this is my object. And now I want to transform the object. So instead of using the transform input, transform output, etc., etc., for the same behavior, I'm going to use move object. Now I connect this to move object, and what move object is going to do is to move the object each time, adding the values I give it here. So it's going to do the same thing we did earlier with a bit more nodes. So let's put this to 3, and that's it, but nothing happens. Why? Because I just created a group. Okay, it's just that I created the code, but I'm not executing the code. So if I go here and I go Shift A, by the way, let me name my group. I can name it to crappy group, for example, because it's a bit crappy. So Shift A, subprograms, and I have here crappy group. And now I have a node that is pointing towards crappy group, and I have an input that is object. I can create more inputs. For example, a float value, just a number, and it's going to appear here. Okay, and I can change the name to number, and it's going to change here, or I can delete it. So now if I connect this to the object, this is going to modify the object. But the cool thing about groups is that I can have another object, for example, a monkey, and I can repeat the same or the same operation. So I can go to subprograms, crappy group. I don't even need to create an object input. I can use the field here, and I can press here, and this is going to affect Suzanne. Okay. But what happens? I'm going to disable auto exclusion for a second, and I'm going to reset the objects, and now I'm going to create another input. So for example, this input is going to be a vector, and we are going to use this vector to connect the values I define to the move object. Okay, that's it. So now I have this object that is going to be affected by this group. Let's enable auto execution with these values. So for example, 1, and this object Suzanne that is going to be affected by this group, but with these values. For example, 3. So now I have the same code, the same group of nodes that is affecting different objects at the same time, but with different values. Okay, but in this case it's just affecting one object. So this is like I'm creating a tool and I want to reuse this tool for many objects, but one at a time. Of course, we could create more complex groups with different loops inside and different things, but this is just an example so you understand what groups are. So let's change this. Let's reset the position of the object. 20, no, 5. And let's delete this group. I don't need these nodes anymore. And now let's see the loops. What are the loops? If you know a bit of programming, you will be familiar with what is called the for loops. Okay, the for loops, they are easy to understand because they are loops that what they do is for this object do this action. It's just that. Usually they are a bit more complex because it's for this object from X number for X value to X value, do this action to this value, something like that. That's a for loop, and that's what's happening here in animation nodes. So for example, I'm going to have 3 objects: the cone, the monkey, and the cube. Okay, let's hide the camera. Cone, monkey, and cube. I have these 3 objects and I want to repeat the same operation in all these 3 objects. How can I do that? I can go to subprograms, loop, and I can create a loop. and my loop is a crappy loop. Crappy loop. But this node is a bit different from the group node. Why? Because we have many more inputs to configure. We have an index output, an iterations output. Those two are just values, and we can check the values with the viewer. Let me drink. We have a new iterator option, so we can press here and create an iterator, for example, object. And check this. We configured this to object, but if I press new iterator and I write object, I don't get just an object. I get an object list, because loop groups work with doing the same operation over a list of objects, an array or a list or whatever you want to call it. So I can select object list, but the output node is not a list, and we will see how the sockets for lists look in a moment. But it's not a list. This outputs just one object at a time, okay? And the operations we do here are going to affect just one object at a time. That's it. Next, we can create a parameter. A parameter, it's a value that is going to be reused at every iteration. So each time the loop is being executed, this parameter is not going to change unless we change it inside the loop code. So let's create a parameter, and this could be like a vector, like before, okay? And let's use the same node as before, the move node. So let's press Ctrl A, move object, and it's just the same, okay? And we can connect object to the object and vector to the vector. That's it. We have a loop, and it's going to go on and on and on up to the infinity. So now, how can we bring these objects here? We have different options. For example, we could try to get the same object input, but this is not going to be too useful. Why? Because we will have to create different inputs for all the objects, etc., etc. This is not useful at all for working with a group of objects or a group of values. So what we can do is to go to object, and we have list. We can create a list of objects to work with it. So now we have two inputs, but we can create one more input, and we can populate these inputs. We select the cone, and now the cube, and now the monkey. And now we have the object number 0, because the list starts by 0. So we have the object 0, the object 1, and the object 2. Okay, we have 3 objects. And now how can we execute this? We go to Shift A, subprograms, crappy loop, or Control A, crappy loop. Okay, we can connect this, and we can modify this value. For example, let's say 2, and all the 3 objects are being modified. Okay, so let's put here 0, and we will do another example in a second. So this was perfectly fine. Okay, 0, 0, and 0, and -5. Okay, but why is this useful? Why not use just 3 object inputs and 3 nodes of the group? Because we can modify what happens to every object inside the loop in a simple way. So for example, let's say that I want to give a different value for each object. So we have index and iterations, okay? And we are going to check what are my iterations and what are my indexes. The index is going to be the object I'm working on. So for example, this is the, This is the 0, the 1, and the 2. How can we check this? We can go to new generator output, and we are going to generate an output that is going to give us information after the loop is executed. So new generator output, we say float list, and we just connect the index to the float list. And we have an output here. We can check the value using a viewer. So viewer, we connect this, and here we have 0, 1, 2. Okay, we could try to connect iterations. We have 3, 3, 3. Why? Because we have three iterations on its execution. Okay, as you can see, this doesn't change. Okay, so we can use, for example, these variables to modify the value is going to affect the move object node. So we can get the vector that we were given, and we can separate the vector. This is the vector I want to separate, and we have x, y, z. So we are going to multiply the value of x, yes, the value of x by the index. Okay, so we go and press math, or we can write multiply numbers. It's the same. The multiply is just like a shortcut to get the math node with the multiply configure, but it's just the same. So we press here, and if we modify just this value manually, we are going to get the same result as before. But if we go and use the index, and then we combine the vector back, as we did at the beginning of the video, the y, the z, and our new x, we connect this here, you can see that nothing is happening. Why? Because we have 0 here. But if we press here 1, for example, this is what is going to happen. Okay, its object is being modified differently. So this is what a loop subprogram does. It's just a for loop. Okay, it iterates over objects and it modifies the objects. I'm not going to go into this in a too complex way, just because this is an introduction. But I don't know if you have any question about loop nodes or loop subprograms. Put it in the chat and I'll try to answer you. So these are loops. Okay, I think they are fairly easy to understand, at least for basic things. It may be much more complex because we can have many iterators, and we can have many parameters of different types, and we can enable and disable things, and we can do many crazy things. We usually use animation nodes for two things: one for motion graphics, and the other one is for generative tools. So we have a scatter tool created completely in animation nodes, for example. Okay, but now this makes the node tree a bit too complex. Okay, why? Because we have to write down a lot of nodes. We have to use a lot of nodes for a simple repeating operation. So since animation nodes 2, this is a very long time ago, we don't have to use loops. Okay, we can use loops, and we should use loops in some complex situations, but for simple situations we don't have to use loops. And with this I'm going to show you, let me delete this. I'm going to show you something that is more near to the example I saw in the beginning. We are going to do a grid of boxes, and we are going to make these boxes to react to some empties. Okay, and as you saw in the beginning of the video, we can work with transforms, output and inputs, but in this case we have a much better feature that are matrices, or matrices. In English is the plural is matrices, I think. we can work with matrices, but don't be afraid. Matrices are not complex. They are very simple in animation nodes. They are very simple to understand, and it's a pleasure to work with them. So let's try this. So for starters, I'm going to generate a grid, just a grid of vectors. That this is going to be a grid of positions. Let me modify this object a bit so it's more similar to my original object. Okay, I'm going to create a grid, so I can create a grid mesh. And this grid mesh is not going to create any object here or here. Okay, this is just information. Those animation nodes come with Blender now, or it's an add-on? It's an add-on, Steve. It's an add-on, and you can download it from graphical.org, and you're here and you can download it. I said in the beginning of the video, so check that later. Matrices. Matrices? How do you call it? Tell me, Derek. How do you call it? Matrices. The matrix. We work in the matrix. So this grid mesh node is going to create information about a grid mesh, but it's not going to create the object. It's creating the mesh just inside the animation node. If I want to create the object, I could create the object. How? I'm going to use, for example, a UV sphere, and I'm going to change this UV sphere into a grid mesh. So I have the grid mesh, and I can write here object output, mesh object output. Okay, and you can see that I get an object matrices. Okay, matrices. I don't like matrices, but okay, matrices. We have an object input that is going to give Blender the information of what object or what container do you want to use to put this mesh on. So in this case, I want to use this sphere. And what is the mesh that you want to use? Hello, Nikoref. We can connect this mesh to this mesh and nothing happens. Why? Because animation node is telling us, hey, do you want to use this? Because you have something connected to this socket. So do you want to use this option? Well, then enable it, please. If I enable this, we get the grid mesh. And we can check the wireframe, and you can see that we get our proper mesh. We can change the divisions and do whatever you want. Okay, so for starters, I want to use just a 6x6 mesh with a length of 10 by 10. Okay, but I don't want the output. I don't want the object. I don't care about the object. I'm not going to use the object, so I can just delete this object and just I'm not going to use it. So next, now what I want to do is to use the information from this object, this mesh, sorry, to relocate a bunch of cubes. But I don't want to create the cubes manually, right? Because it's a nonsense. If I want to create 100 cubes, I don't want to create 100 cubes manually. How can I do it? Well, it's pretty easy. What I'm going to use is a node that is called object instancer. So I can go Control A, object instancer, and this is going to instance any object I want. In this case, I want to make instances of this box. So I press here because I have the box selected. I press here, and that's it. But nothing happens. I don't have any object instance. Why? Because I have to specify the amount of instances. So I can go here. You send me a link on Discord on how to pronounce. Great. Thanks, Derek. I will learn to pronounce matrices. In the next streaming, I will be pronouncing matrices much better. So I can indicate animation nodes to create any amount of instances. For example, I want to create 10 instances, and suddenly I have 10 instances. They are unique, they have unique names, and they just work. I have 10 objects more. But these 10 objects, these 10 objects are located in the 0, 0, 0. Okay? I can delete them, delete them using 0, and they disappear. But now let's think, okay, if they were created in the 0, 0, 0, and my object is in the 0, 0, 0, I can move this object, and then I can create the instances. But no, they are created in the 0, 0, 0, 2. Okay, every instance is going to be created at the 0, 0, 0. Okay, in the center of the wall. So how can we relocate these objects where we want? Well, for starters, what we are going to use is that we are going to use information from the grid mesh to generate the exact amount of objects that we want. So we want 6 by 6. For that, we have mesh. We can use mesh info node, and this mesh info node is going to give us a lot of information. We can connect the mesh to mesh, and if I use a viewer and I drink a bit, or I won't be able to talk. Hey, Chatomante. If I use a viewer and I check vertices, I get 36 vertices, okay? And I get the position and the information about the vertices vectors. So I get 36 vectors, but I need a number, not a list. And this number is a vector and it's not a number. And what can I do? Okay, don't be afraid, just connect it. Sometimes it works. Why? Because it's smart enough to create the node you need. And the node you need is the list length. Why? Because it's going to give you just the number of the amount of values you have in this list, in this collection, in this array, in this list. So right now it just created 36 objects, 36 instances. Now we have to position these instances, those instances, in those values, in those vertices. How can we do that? Okay. For that, let me go a bit more slower. For that, we can use the value replicate matrix. Okay, so we can use replicate matrix. And we are not modifying the matrices yet. We can use replicate matrices, and we can use just the vertices. We can change vertices to vectors, and we are going to generate different matrices for those vectors. Okay, and as before, we just have to output this into something. Okay, so let's use matrix output, object matrix output. And here is the cool thing about animation nodes, and why we don't need to use loop subprograms constantly. This is because we have a list output here, a list socket, and you can see that this socket is kind of half transparent, but this is a solid socket, okay, because it's just to get one object. But if we connect this to this is going to turn into a list socket. It's going to accept a list, and it's going to apply whatever is happening to that list of objects. So now we connect the matrices to the matrix, and boom, we have our objects with the correct transformation. We can modify this grid, and we are going to modify our objects, or we can increase the amount of instances. Okay. Increase this a bit. Okay. So for example, so now we have a grid of objects procedurally configured, but and this is when the coolest thing of animation nodes comes in, and the simplest things, one of the simplest things on animation nodes. How can we modify the position of this object? So we have a tool here that is offset matrices, offset matrix. No, offset matrices. Yeah, offset matrices. And we can connect offset matrices. Sorry for my Spanish. Matrices. Okay, thank you, VLC. Matrices. Derek, can you confirm that? Matrices, no matrices. 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 I can connect these matrices to this matrices input. And now this matrices output to this matrices input. And now I have the option to pick if I want to modify the location, the rotation, or the scale. So for status, I'm going to modify just the location, okay? So location, and nothing's happening. But if I change this value, everything is changing. Okay, cool. We are doing the same thing we did in the past. That's good. Okay, matrices. Matrices. We are going to modify the location, and if we press play, it's not going to go crazy. Okay, it's not going crazy. It's just it modified, it's executing, but we are modifying this matrix just once with this value. Okay, that's cool. But now I want to control this because I don't want all the objects to be modified at once. Okay, I want to control when every object in the collection is going to be modified. So for that, we have something that is called falloff. If I configure this to 10 and I modify this falloff, you can see that at 0 is not going to affect, at 1 is going to completely affect. If I go to rotation, for example, and I modify this to 90 degrees, 0 and at 1, okay? Super simple. Super simple. And how can we control the falloff so it affects only the objects that I want? We can use an empty. There are many different types of falloffs. We can go here and we have here falloff, and you can see that we have a lot of falloff. For example, we have wiggle. We can use wiggle. We connect wiggle here. Let me go back. 0. We connect wiggle here, and now you see that everything is crazy. Okay, and we can modify the evolution or the seed. Yeah, the evolution. Okay, and we can, for example, generate a random number, and this is going to get a bit crazy. I think the random number is not the best option, and we're going to generate a random number from 0 to 100 and connect to the evolution, and it's not going to change it, of course. Sorry, we are going to use a time info node because I want the number of frame, the frame number, to be used in the evolution. So if I connect frame to evolution and I press play, we have this moving. Okay, and now we can increase the amplitude or the offset or the octaves, say 3, and the persistence is going to be 0, for example. And we can configure these to 360, so they go the full, and these to 1 or 5. Okay, but this is modifying each object differently, but we want to control when these objects are going to be modified. So we can use a different type of falloff. We delete this. And now we are going to use a falloff that is called object controller falloff. Object controller falloff. And for that I need an object. And that object, it could be any object you want, but in this case, in this example, I'm going to use an empty. Let me break. Matrices, and I'm going to use an empty. And a sphere, for example, I have my empty here, and I this I have empty, and I control. I connect this falloff to this falloff, and now if I press play, you can see just when I press play that these two objects has been modified. And here comes what I said before. How can I do animation nodes to react? How can I provoke that animation nodes is going to react in real time to all this? Well, this is pretty easy. I told you that we have auto execution and we have tree changed, frame changed, and property changed. But there is another thing, that is new trigger. So we can pick this trigger, we can pick this object and drag the object here, and we can get what property is going to drive the execution of the node tree. And in my case, let me configure this to 0, no, to 1. In my case, it's going to be scale, in this specific case. And keep in mind, this is just for execution, okay? This is not affecting the actual node or what the actual node tree is doing. So, right mouse button, copy data path, and paste. And if you know a bit of Python, just scale or position or rotation. And now that I have this, if I scale the object, it's going to affect in real time. I don't have to press play or anything. It's going to affect in real time. If I move the object, it's not going to affect. Why? Because I need to create a trigger. So I'm going to repeat the operation. I drag the object, and here I think it was position. No, it's not position, it's location. I think it's location, but I prefer to copy data path. Yeah, location. And now this is affecting the object I want. Okay, great. So let's animate this a bit. Let's create this a bit bigger, and let's animate. Let's say we are frame 10, and we go this and this. Now we go to frame 40, X here and here. Okay, and that's it. Okay, and if I set a key in the location, it could be good also. Okay, and now I don't want to modify the location or the rotation of the objects. I just want to modify the scale. So let's disable location or rotation. Let's enable scale, and let's write down 0. Why 0? Because I'm going to invert the way the file of work. So instead of going from the actual value the objects have to the actual value I write down here, it's going to do the opposite. So it's going to go from the actual value they have. Well, it's better if I show you. So I press invert, and now this is the actual value they have. So if I press play, okay, let's modify the camera and use the camera bit, and let's increase this time to do it like more slowly. Okay, and now we can do another thing, because right now this is like too sharp, it's like too fast. So we can increase the file of width, and with this width we can increase the effect with a bit more distance. So now if we press play, there's going to be a more gentle movement. Hello Michael. Nah, don't worry, you will be able to watch the streaming later, because I'm going to finish. We are on 1 hour and I'm about to finish. So let's give this a value of 10, and now we can change the interpolation. We may have different types of interpolation. We have, for example, the elastic one. Okay, or we have the bounce one. It's similar, but it's not exactly the same. Or we have the back one. It's more subtle. You can see that it goes a bit further and then it goes back. But the cool thing about this is that we can create our own interpolations. So there's different tools to do that, but there is a cool one that is what is it? From Cube. So we can create our own interpolation curve. We connect the curve to this, and now we can go crazy, and we can do this, and we can do this, and then you go this, and then you go here, and where you want. Okay, and we can go this, and we can go crazy, and that's it. And this is going to be a bit crazy, but it's okay for the example. So we press play, and we have this. Okay, and if we modify the curve, we're modifying the behavior. I don't like that we cannot make this window bigger in the head, but okay. So we can, for example, this, and this is going to be to 0. Okay, so we can create our own interpolation curves, and with this we can reach very cool effects. No way, this is going to 1 at the end. Okay, so it's pretty cool. Now let's say we have the modification we want. It's okay. We have exponential, and we have our objects appearing. But now we want to do a different modification. We're going to make the object rotate. Okay, the same that you saw at the beginning of the video of the streaming in the effect I showed you. So for that, we can concatenate, we can use several offset matrix. So we go here, offset matrix, offset, oh my god, offset matrices. We use offset matrix. Another one, we connect this here, and we can use a different falloff. So we can use another object. Let's create another empty. In this case, I'm going to use a cube just to have a different shape. We can put this cube here, for example. And I'm going to set some keys. Let me check. This has ended. Okay. Yeah. So this is going to go here, and now I want this to go over here and be bigger. Okay. Matrices, yeah, matrices. I think I'm going to rename this live streaming to the matrices streaming. Okay, now I just have to do the same. So I go to rotation, and I want they are going to rotate like in X and Y. No, just 180. And let's use the same object controller falloff. Let's connect falloff to falloff, and let's use the empty 001. And now you see that it's affecting already. We press play. We have our objects appearing, and now we have our objects being rotated. We could use just one axis, for example, this one. One here, and here a bit farther. Okay, and that's it. That's the exact same effect I did at the beginning of the video. So we can modify the effect by changing, for example, the scale, or do the effect we want. We can do whatever we want. And as you can see, we are using just a bunch of nodes. It's not as complex as using loop subprograms. It's not as you don't have to have a big mess of nodes to do this kind of effects. This is more similar to the Cinema 4D effectors, I think. I never used Cinema 4D, but some people told me that this is similar to the effectors in Cinema 4D. So if you're curious, just use animation nodes and investigate all the fall-offs in this same example, how they work, how they can do, because they can do a lot of things. So I think that's it for today. 1 hour 6 minutes. I think it's more than enough. I hope you liked it. I hope you understood the very basics of how animation nodes works. How can you use it to do simple animations, to do cool things. Keep in mind that animation nodes support a lot of things. It supports a lot of things, like grease pencil. You can use grease pencil, you can use particles, you can use whatever you want. It was a bit unstable the 2.8 release, but now it's pretty stable, and they even fixed a problem that it had with Alembic export. So now you can export your animation to Alembic, or you can bake this to simple objects with where is it? With the bake button that I don't know, here in overview. With bake to keyframes is going to disable the node tree, and it's going to bake the animation it's doing to keyframes. But this only works with animations that don't need to modify the actual geometry. If you want to modify the actual geometry, don't bake to keyframes, just export to Alembic, and that's it. Greg, you need to get into animation nodes. Yes, I agree, you need to get into animation nodes. Keep in mind that this, while it's not the same, in fact, it's not the same at all, but while it's not the same, it's going to be useful to know some animation nodes to be able to use function nodes and particle nodes. Because in the end, the developer is the same. So since it's the same one, there are things, there are concepts that they are going to be similar. They're not going to be the same, because Jaxlook is changing everything, and it's really studying hard, and it's really doing a great effort and a great development with particle nodes and function nodes. But some concepts are going to remain the same, I'm sure. So knowing animation nodes, it's like taking leverage of your knowledge for the future versions of Blender. So it's really cool. It's a really cool tool. You can create animations, but you can also create tools. Okay, not just animation. Keep in mind that this can modify meshes. This can do pretty much whatever you want. So that's it. That's it for today. Thank you for watching the live streaming. I hope you liked it. I hope you enjoyed it, and I hope you learned something. And if that's the case, awesome. Please, if you like it, press the like button, subscribe to the channel, and press the little bell if you want to know more when I do live streamings. You can also follow me in Twitch. We have a Twitch, and I do some different live streamings in Twitch. The last one was in English and was about LuxCore, the render engine. It's pretty cool. We are using it already, and it's a very cool render engine with caustics. Yes, proper caustics, and it's very similar to Corona Render. So I think you should at least try it. And follow us on Twitter or Instagram with Bone Studio Anim, at Bone Studio Anim. And that's it. See you in the next live streaming. Thanks everyone. Bye.